Today I want to talk about funds tracking, how to investigate on chain. To do that, we're going to use Phalcon, a tool from Blockstack, which allows us to do different things that would be otherwise very complicated, like simulations, debugging transaction, and following account changes to a more detailed point. For us to do this analysis, I'm using a transaction for arbitrage bot that was able to extract $20 on chain. Let's take a look on how that looks like. We can see the fund flow tool here. And at first, looking at this, you may feel that this is a little bit confusing, hard to follow, but you just need to digest step by step and follow the transactions, and you're going to come to the conclusion. So here you can see that the user first gets a fresh load and phone balancer of almost $150,000, deposits into Curve and gets Curve USD. Then after that, on step 4, he swaps his Curve USD to DAI, gets the DAI, makes the operations, and comes out in the end with 19 USDC. And it's very important to really consider and taking your time to evaluate this, because these tools can really show you where the money went, if it came from the same criminals, and how they are distributing it. And just to show you a little bit of a more complicated case, I have a flash loan attack here that happened some time ago in a protocol, but you still have the numbers representing which step happened, the color representing a different token change, so a different asset being traded or set around. And we also have the arrows showing the fund flows itself. So remember to visit Phalcon, put in the transactions, and explore and learn how to use this part of the tool. Thank you. Another really cool aspect of investigating the chain is checking out balance changes. During some attacks, sometimes it's not really obvious who got the money and who got paid in the process. I have a really interesting case here to showcase the situation. The honey money exploit. The protocol was drained of $800,000, but the attacker only had half in the end, so what happened to the other half? Let's check it out. We'll just paste the transaction for the attack here, load it. Now when we go down to the balance changes tool, we can see how all the addresses in the transaction got their balance updated. We can see everything being burned and mint, and we can see the whole process to the end. And curiously, checking out how much the exploiter itself, the MEV bot, paid, it made around 250 per ether at the time, $400,000. Checking out and going down a little bit, we can see that the MEV bot actually paid an MEV builder half of the attack money in bribe just to make sure this transaction would be minted. So it's really important whenever following money, whenever tracking transactions, to understand how all the accounts in the process benefited. Phalcon also allows you to see what changes in the state happen in different smart contracts during the transactions. And needless to say, it's highly useful. And we can see the case for the Tornado Cash attack here, where the hacker was able to manipulate 100 addresses of the governance contract. Really important to check these values to see how the state behaved during the transaction. It can reveal very important information. Sometimes looking at smart contracts behavior is not that obvious. Trying to optimize a smart contract, try to understand which pieces of the code are using more gas, really hard. Let's take a look at the gas profiler from our dear friends Blockstack and Phalcon. So just by looking at this smart contract gas profiler, this transaction gas profiler, I can see a few interesting things. What are these? I have three create contract operations. You see, they all have and consume the same gas. I also have here different withdrawal operations, and you can see the balance too, which and you can see that they consume the same amount of gas. Now, what can be concluded out of this is that this code is most likely doing the same thing, even that's being in different smart contracts. And how interesting it is to see and have that vision. You don't see the code, but how the gas is used to kind of have an idea that this code is related and it must be doing the same thing. We have the same pattern, small bar, bar, small bar, bar. Now let's take a look in the end, and you can even see other operations like Uniswap callbacks and transfer from all the gas costs, and helps you to try to understand a lot of what happened and how the players are behaving. Dealing with an invocation flow can be a really consuming process. Luckily, Phalcon has a lot of really nice tools to deal with that. The first one I want to show you is the highlighting tool. So let's say I want to see all places this address is being used. I can just click here. Let's pick green. See how the address pops out everywhere? This is so much easier to see. Oh, even better than that, I can tag it. Let's tag it. Let's call it Explorer. And there you go. So now, instead of making reason of some strange address, I can just refer to it as a name. And this involves a lot of flash loan calls, as we can see here, but the started calls in the way really pollutes the resume. So we can just disable them using. How awesome is that? And not only that, I can also search for the functions. So let's say approve. And there we go. All the functions are there. This is an amazing tool for you to do your research. One of the most interesting aspects of Phalcon is being able to debug transactions. Right here, we're looking at the transaction that did the Euler hack, and we know that the error itself occurring the function donate to reserves, so we can just search donate here. Once we did it, we're gonna get a list of call that leads to that function. Let's click it. Now, what is really interesting here is you can click this debug button, and you're going to be able to debug the whole transaction itself. This is really, really amazing. We can see that before the donate reserve happens, we had a mint function. Let's try to look into it. We can call stepping to drive into the function. And we can see some sort of box implementation here, token dispatcher. Now we are in the mint function itself, and we can literally execute each line as it was code. And I can also go to the previous line, step out of this function, step out of this function, and just go to the next execution. So this is an amazing way of debugging your information. The interesting thing to see is you always get the parameters and everything here in the zone field, get the whole inflow of execution, and you get the line by line track parameters. So this is a really, really, really amazing tool. And gotta tell you guys, this is so much better to use if you have two screens. Just click this button here, and you're gonna get a really nice way of displaying this information, and it's gonna be so much easier for you to see. And you can also call and adapt the parameters, so you can see everything that was passed here. So this is also quite useful. You don't need to lose a lot of time looking into this data. Also the same for gas. This is something simply magical done by the BlockSec team.